Okay, so today we're going to be doing an experiment to get familiar with the glassware and some of the other instrumentation we'll be using in the lab. So the first thing to do is we need to look at each piece of glassware and determine some of the increments on it, the error associated with it, and more importantly, how to measure from these. So the first thing we have is a 125 milliliter Erlenmeyer flask. If we look, the increments on it are all marked. We have 50, 75, 100, so that means the volume of our increments is 25 milliliters. The error on the glassware actually says plus or minus 5%. And then the next thing we want to do is to get the density of water contained in one of these. We'll use these to compare how accurate they are. So once you put the glassware on the scale, you can tear your scale. That basically just removes the weight of the glassware because we don't really care about the weight of the glassware. We need the weight of the water inside it. So what we want to do is fill our glassware up with some water, but we specifically want it to be between two incremental values because that'll help us really measure the volume to the right number of decimal places. The decimal places of any of your measurements are dictated by the glassware itself. So if we look, our water is between two of these increments, so it's somewhere between 50 and 75, so we could estimate that's maybe 67 milliliters. Our lower mark is 50 milliliters, our upper mark is 75, so we can estimate between those values and get, say, maybe 67. Now, if you were doing this in person with a lab group, each of you might have a slightly different volume measurement because you're estimating that value. And if we record our mass, we have 60.83 grams from the scale, and we'll calculate our density later. I'll do all of the calculations separately at the end. And we're basically just going to do the same thing with each of our pieces of glassware. So make sure after you pull the glassware off that you zero the scale back out before you put the next one on. The next thing we have is a 100 milliliter graduated cylinder. Put that on, tear it out. And this time we have marked increments every 10 milliliters, but we also have marks between these. Each of these marks actually comes out as 1 milliliter increments. There are 10 markings between 10 and 20, so each of those markings is going to be 1 milliliter. The error on these, that one didn't have it, is plus or minus 0.06 milliliters. So not a percentage like the Erlenmeyer flask was, but again, the error will usually be marked on the glassware itself. So now we're going to do the same thing, fill it up between some incremental values. Just for consistency, we'll make sure that it's at least or somewhere around 50 milliliters, but again, between two incremental values. Because again, that's the important part. We want it between the incremental values so that we can estimate. There we go. So the important thing about taking volume measurements out of glassware is the water will actually curve and create something called a meniscus. And that curved surface you want to measure from, this was the meniscus, you want to measure from the bottom of it. Well, to accurately do that, you need to be at eye level, which is why I'm down here like this. So let's see, that's between 53 and 54 milliliters. So that means we'll need to estimate something between those, meaning our measured volume will have 1 decimal place. So I'm going to say about 53.3. And we can already see between the graduated cylinder and the Erlenmeyer flask, we have different decimal points associated with our measured volumes because of the way the increments are broken up. The mass for this one is 52.50. grams. And again, since we're measuring the mass for all of these, we want to measure them on the same scale at the same time. We don't want to be moving scales because each scale has a slightly different error. So next we're going to use our 100 milliliter beaker. Again, doing the same thing. Our markings, the numbered markings are every 20 milliliters, but we do have a mark between them. So that means each of our increments in this case is 10 milliliters. Error written on it is plus or minus 5%, similar to our Erlenmeyer flask. Zero that out and fill this up around 50 milliliters, but again, needs to be between two of the measured values. Let's try that. Yeah. There we go. So this time it's between 50 and 60, maybe 52 milliliters. And because we don't know precisely where that falls, our ones digit is our estimated digit. And the mass for this one is 49.82 grams. Okay. Now we get into some of our stranger glassware. It's called volumetric glassware. Volumetric glassware only has one increment on it. So for our 50 milliliter volumetric flask, because there's only one increment, the value of that increment is going to be 50 milliliters. We do have to fill these specifically to their line, again, because there's no increments to estimate between. The error on this one says plus or minus 0.10 milliliters. And what you'll notice in the data tables is we have the upper and lower increments blacked out because we can't get to between two increments. So this one I'm going to fill up exactly to the 50 milliliter mark. And as I get close to that, that means I'm going to need a transfer pipette to get it right to the line. There we go. It's pretty close. I'll use a transfer pipette to get it the rest of the way. So after tearing the scale, mostly filling it up, I'm going to get it the rest of the way exactly to the line. And again, I need to be at eye level to make sure that the bottom of the meniscus is right at the line. There we go. So in this case, because it says our error is 0.10 milliliters, we can record our volume to 2 decimal places. So our measured volume in this case will be 50.00 milliliters. And our mass is 49.79 grams. So our last piece of glassware is the volumetric pipette, and this one's even a little stranger. It is specifically a to-deliver piece of glassware. So because of this, it's open on both ends. If I were to try and put water in it and measure it, it's not going to work. So what I'm going to do is I'm going to fill this up and then dispense it into another container. But the volume is going to come from measurements on this. So this one, again, only has the one increment for 50 milliliters. So the value of it would be 50 milliliters, but its error, like the volumetric flask, is also plus or minus 0.10 milliliters. So to fill a volumetric pipette is interesting. You'll need a bulb, and the easiest way to do it, squeeze it out, make sure your pipette's in your solution, in this case just water. Don't put it all the way on the bottom, it won't suck the water up quite as well. You'll set the bulb on top, release, and it'll start pulling the water up. Now, very, very rarely can I actually get a full 50 milliliters out of a single bulb pull. Let's see. Yeah. So what I'm going to do is set it down, and here's the important part. As soon as I pull the bulb off, I need to cover it with my thumb. If I don't, it starts draining out. So I'll cover it with my thumb, squeeze the bulb out again, and pull the water up. Again, I need to get it right to the 50 milliliter mark. Oop. Now it doesn't want to pull. There we go. Best way to do it is to overfill it and then take the pipette and twist it slightly. It will slightly break the seal with your thumb. Sometimes you can roll your thumb around as well. You don't want to just pull your thumb off, it'll drop too quickly. So if you turn it slightly, it'll drop down. If you drop below the mark, just pull some water back up. And you'll keep twisting it until you get the meniscus right to the increment. This is one of the pieces of glassware that takes the most patience to use. So once you get it exactly to the line, we'll go ahead and dispense it into our beaker. Again, as for the volume measurement, because this measures 50 milliliters exactly, and the error is 0.10 milliliters, the volume in our data table will also be 50.00 milliliters. One of the important things to note, we're looking for density today, and density changes slightly with temperature. So we do need to know the temperature of the water we're using. Go. It's all of the water. You may notice there might be some water stuck in the tip. That's fine. Do not blow it out with the bulb. It's actually calibrated to include that little bit of water in the tip. So 49.73. And the temperature of our water is, again, like any measurement, if you've got increments, you want to figure out what those increments are. In this case, all of these are in 1 degree increments, so we'll estimate between those values to something that has 1 decimal place. So 22.7. 22.7 degrees Celsius. We provided you guys with a table. 22.7 is pretty close to 23, and we'll just copy down that density. And then at this point, we'll go through, we'll calculate our densities and get our percent error for each of these pieces of glassware, which will be done in a separate section.